Now, there are three types of elasticities, and the concepts and the definitions you really need to learn and really need to be aware of how to calculate them. So the three types are the own price elasticity, which is usually referred to as EPQ. Then the other one is the income elasticity, which is referred to EMQX, and the cross price elasticity, which is usually referred to EPYQX when you're comparing elasticity between two products. Now, as I mentioned at the previous slide, negative numbers come into elasticity quite a bit, so let's see how we can use the negative numbers in elasticity calculations. So there are a few ways of calculating elasticity. The own price elasticity is calculated by the percentage change in quantity divided by the percentage change in price. And if you have got that formula, you break it out what the changes are, then you will find that it can be rewritten as a slightly different format. So the EPQ can also be calculated by price over quantity times the change in quantity divided by the change in price. So depending on what information is given to you, you would use one formula or the other. Now, the change in price, be aware, is that it's slightly differently calculated than we would calculate a simple percentage change. So the percentage change in quantity is still the final quantity minus the initial quantity, but now you divide it by the average. Same for the percentage change in price. But how do we calculate the price average or the quantity average? So the Q average is equal to the sum of the two quantities divided by the number of quantities, which is 2, and the price average is calculated similarly, the sum of the two prices, again divided by 2, because when you're calculating the average of two products, you are dividing it by 2. One more important thing, and this is where the negative numbers come in, that when you're talking about elastic, inelastic or unit elastic demand, then the own price elasticity is either bigger or smaller or equal to -1. So you will talk about elastic demand if the own price elasticity is less than -1. You're talking about inelastic demand when the own price elasticity is bigger than -1. And you're talking about unit elastic when the own price elasticity is exactly -1. So that's why we looked at comparing numbers to -1 in the previous slide. So let's look at some exact calculation questions. So what is the own price elasticity? So I need to be able to calculate EPQ, that's what I need to find. Of chocolate, if quantity demanded for chocolate falls by 7% when price was increased by 12%. So quantity demanded, so that is the percentage change in quantity, and it falls or decreases are negative change, so we have got -7% in the percentage change of demand. And when the price changed, the price change was increased, so it will be a positive change, and that is 12%. So the formula is up on the board. So what you can see here now is you just need to substitute the right quantities into the formula. So at the top will be the percentage change in quantity, and at the bottom will be the percentage change in price. So the own price elasticity therefore will be -7% over 12%. So scientific calculator again, fraction -7 come down to 12 equals, so the own price elasticity is -0.58. Next question is chocolate elastic, inelastic or unit elastic? Okay, so remember, elastic was when EPQ is less than -1, inelastic when EPQ was bigger than -1, and unit elastic is when EPQ is exactly -1. Now, looking at our answer, we can say straight away that it's not unit elastic because it's not exactly -1. Now, the question is it smaller than -1 or is it bigger than -1? Well, this is closer to 0, so this is actually bigger than -1. So what we have here is an inelastic product. Let's look at another example which is slightly different. Again, we will make use of the on-price elasticity formula, which is the percentage change in quantity divided by the percentage change in price. So what we know now is that the on-price elasticity is -1.2, and the question is what will happen to demand. So what is the percentage change in demand if we know that the price of the apple increased? So increase is positive change, so we've got the positive 20% change. Looking at this formula, let's put in the exact numbers and see how we can deal with that calculation. So on price elasticity is -1.2. That has to be equal to the percentage change in quantity, which we don't know but want to be able to calculate, divided by the percentage change in price, which is 20%. Well, that's a relatively simple formula. All we need to do now is multiply up by the 20% both sides, and we'll be able to calculate the percentage change in quantity. So -1.2 times 20% will be equal to the percentage change in quantity. So call the scientific calculator. -1.2 times 20, that is equals to -24% is the percentage change in quantity. What does it mean for us? Well, it means for us that when the price increased by 20%, the demand for chocolate will decrease by 24%. One more example, and it's still around the own price elasticity. So EPQ equals percentage change in quantity divided by the percentage change in price. In the question, we know that Fizz Pop's own price elasticity is -1.4. Question is now, what will happen to the price, not to the quantity as in previously, but what will happen to the price if demand fell by 5%? So the percentage change in demand fall, so this is a negative change, and by 5%. Use these numbers, put them back again in the formula, and try to see what we can do. -1.4 is equal to -5% divided by the percentage change in price, which we will need to be able to calculate. So, to calculate the percentage change in price, what I need to do, I need to multiply up by the percentage change in price, but then at the same time I will need to be able to divide it down by the -1.4. So the percentage change in price then will be -5% divided by -1.4. So what will that give me? I know that negative divided by negative will give me positive, so I can just simply type in 5 over 1.4. So that is 3.57 to 2 decimal places. So which means that as demand fall by 5%, price will increase by 3.57%. Now, one last example around on price elasticity, which is slightly different. So EPQ equals the percentage change in quantity divided by the percentage change in price. So the price of laptop increased from 500 to 580. So the original price or starting price of the laptop was 500, and the final price become 580. Demand for laptops hence fell by 10%. So that is the percentage change in quantity fell, decreased, so that's negative, and 10% the exact amount. The question is the own price elasticity. Now, to be able to calculate the own price elasticity, we need the percentage change in price, but we only have got the starting and the finishing price. How can we calculate the percentage change? Remember that a few slides ago I showed you that the percentage change in price can be calculated by final price minus initial price divided by the average price. Now, the average price was nothing else but the two prices added together divided by 2. So with using the exact numbers, the percentage change in price then can be calculated as 580 minus 500 over 580 plus 500 divided by 2. Now, here again comes in the usefulness of a scientific calculator. Without a scientific calculator, what I would need to do, I would need to calculate the average first, then the difference, and then divide them. But with the scientific calculator, I can just put it all in once. I need a fraction. On top of the fraction, I need 580 minus 500. And at the bottom of the fraction, I need another fraction. So I'm going to press the fraction button again. And at the top of the bottom fraction will be 580 plus 500. Come down again, put the 2 in, then come out all of them, and then hit equal. So that gives me 4 over 27, which is equal to 0.148, which is roughly 0.15, and that is exactly 15%. Why do I know it's 15%? Because every time I need to convert something into a percentage, I just need to multiply by 100. So the percentage change is 15%. So go back to the original calculation, which is the own price elasticity. Now I have got the percentage change in the price, which is a positive 15%. So the own price elasticity, therefore, will be minus 10% divided by 15%, and that gives me minus 10 over 15 minus 0.67 to 2 decimal places. When it comes to elasticity, own price elasticity isn't the only type. Sometimes you might need to calculate the income elasticity. And the income elasticity, which is EMQX, is calculated by the percentage change in quantity, but in this case now I'm dividing it by the percentage change in income. So basically I'm actually testing here is how sensitive the product is to income changes. So let's look at an example. If the income elasticity for champagne is 0.6, so I know that EMQX equals 0.6, then what will a 30% increase in income, so that's the percentage change in M being equals to 30%, lead to in the demand of champagne? So what is the percentage change in demand of the champagne? So put the numbers into the formula. So 0.6 is equal to percentage change in quantity of X over the 30%. So again, to calculate the percentage change in QX, I just need to multiply it by the 30. So 0.6 times 30. That gives me 18%. So a 30% increase in income will lead to an 18% increase in demand, given that the champagne's income elasticity is 0.6. Now let's look at the last example in elasticity, and this one's also an income elasticity question. Now, you are the manager of a supermarket and know that the income elasticity of organic butter is exactly minus 0.8. So EMQX is equals minus 0.8. Due to the recession, you expect incomes to drop by 20%, which telling you that the percentage change in income equals minus 20%. How should you adjust your purchase of organic butter? Well, what will happen to the demand? That's the question in here. So, should you order more or should you order less? So let's put the numbers into the formula and let's see what they tell us. So minus 0.8 is equal to the demand that I don't know divided by minus 20%. So similarly to the other case, I need to multiply up. Negative times negative will give me positive. So 0.8 times 20 will give me positive 16%. So what it means, it's because of the elasticity, the income elasticity of organic butter, even though there will be a drop in income, I still expect an increase in demand. Okay, so be aware of that. Depending on the elasticity of the product, sometimes a drop in income could still lead to an increase in demand.